EcoBoost and how it fits in the Taurus SHO. EcoBoost is a set of engine technology that provides the customers attributes. And in this case, what we're doing is the EcoBoost engines provide consumers more performance, better fuel economy, and lower CO2 emissions. Can I take that through? And that strategy is consistent for EcoBoost. So what we've done in all EcoBoost engines, what we've done is we've combined direct injection with turbocharging and engine downsizing to give the consumers improved fuel economy, lower CO2 emissions, and improved performance. And that theme is consistent for all EcoBoost. The idea that a V6 EcoBoost engine will replace a V8, and eventually an i4 EcoBoost engine will replace a V6 engine. So 3.5 liter EcoBoost available in the Taurus SHO, 365 horsepower at 5,500 RPM, 350 foot-pounds of torque from 1,500 RPM all the way up to 5,250. We couple that with a 6-speed transmission with paddle shifters, manual mode. We make that to an all-wheel drive system to put all this performance on the road, which can be pretty good for today. Now, part of Ford delivering an EcoBoost program like this, delivering the Taurus SHO, was making sure it was durable and reliable, lived up to the Ford quality and reliability name. So testing was an important part of our program. We had over the equivalent of 1 million miles of vehicle durability. Some of our tests were 360 hours of straight engine dynamometer operation at wide open throttle and peak torque. We did all our durability testing was done at redline and max boost, making the full 365 horsepower. One of our tests is 1,000 sequential hot and cold starts to make sure that the customers can do that. And then another example is we do 1,000 hours, which is over 50 days of continuous operation at sustained peak in horsepower. All this to deliver the customers vehicles and engines they can trust. The turbochargers were an important part of delivering reliability and durability. The turbos are designed for 150,000 miles of service. They're engineered to operate at 170,000 RPM at temperatures over 1,740 degrees. We survive a test that's 1,500 10-minute cycles of peak temperature followed by extremely cold temperatures. One interesting thing about today's turbos versus the previous generation turbos, we use both an active and passive water cooler. While the engine's running, the water pump pumps coolant through the turbocharger to keep it cool. But when the engine turns off, the water pump stops turning. Our water system still keeps the turbochargers cool. The process is called thermal siphoning. What ends up happening is as warm water is next to the turbo, it rises away and is replaced by cool water coming in behind it. That process continues even though the vehicle's off until the turbos reach room temperature. That's what allows the turbos to have a good, reliable durability and not coat bearings. There's two kind of brackets of technology. Shown on the left is the base engine technology that's either been enhanced or upgraded. So we're using variable camshaft timing. We're using a relatively high compression ratio for a turbocharged engine, 10 to 1. We have oil-cooled pistons with fully machined piston domes. And we have higher alloy crankshafts, connecting rods, and cylinder blocks. That's all established a good architecture for us to put technology on. That technology, direct injection fuel systems, and dual water-cooled and oil-cooled turbochargers. There's also been a few fundamental changes to the architecture of the engine. Fundamentally, this is the same engine, the 3.5 liter that's in the Taurus and the Edge today. What we've done is we've made a few architectural changes. No architectural changes, but a few functional changes. We've changed the compression ratio. We've detuned it slightly, but it's still high for a turbocharged engine. We've changed the camshaft time to optimize it for turbochargers and for fuel economy. We've reduced the max engine speed just slightly because turbocharged engines don't need to rev like naturally aspirated engines. What's all this mean to the customer and to the engine? 365 horsepower at 5,500 RPM, 350 foot-pounds of torque, flat torque curve from 1,500 RPM all the way up to beyond 5,000 RPM. This is what gives the car great personality, great driving experience, and a real confidence when you're driving on the vehicle. How does it stack up to our competition? Taurus has a dual role in our lineup right now. It's our performance sedan, which I'll show you here, but it's also a luxury sedan, which I'll show you next. Looking at our performance sedans, we're showing you here is the Pontiac 6-liter, the Dodge 5.7-liter Hemi, and the Chevy 5.3-liter. And you can see the green zone where customers spend 98% of their drive time. We outperform our competitors in this area. At 70 miles per hour, we have over 50 foot-pounds of reserve torque available. And again, that gives the customer driving confidence, it gives them the ability to accelerate, and the ability to merge on the expressway effortlessly. Kind of putting that together in a table, you can see that we made 365 horsepower versus competitors 361, 368, and 303 in this case. So very competitive with the performance sedans. But as we promised fuel economy. So in this case, we're giving you 25 miles per gallon versus the competitors 24 and 23. Now looking at Taurus as a luxury car, we've compared it to some of the luxury segment. Cadillac, Audi A6 with 4.2 liter, and the Lexus GS460. And you can see in this case, we clearly dominate the competition. We have more peak horsepower, we have more peak torque, and again, where customers spend most of their drive time, we have substantially more torque than they do. Again, giving the customer, giving the vehicle a great driving experience, great nimbleness and confidence. Showing to this at the table. Again, reiterating, we promised 20%, we're delivering 25% versus the Infiniti M45. 25% better fuel economy and more horsepower, 325 versus our 365. Now other vehicles, 320, 350, 342. So more power, better fuel economy, and then lower CO2 emissions to go with that, lower fuel economy. Torque translates to a customer in 0 to 60 times. 0.8 seconds faster than the A6, 0.8 seconds faster than the Cadillac, 0.3 seconds faster than the 5.7-liter Hemi and the Chrysler 300. This is confidence. This is the ability to outperform the customers, their competitive segment. Take a look at that in the summary. These are the vehicles you're going to be driving a little later today when you stop at a brake stop. We're kind of giving you a summation of where we're at. We're getting 25 miles per gallon on the highway versus our competitors 23 and 23 respectively. We're getting 365 horsepower versus our competitors 360 and 350. But again, I want to remind you of that torque curve we talked about a little earlier. That broad, flat torque curve, we're delivering between 50 and 80 foot-pounds more reserve torque at a speed of like 70 miles per hour.